I'm Katie Biggs.
Hi, I'm Hazam Gabala.
I'm James McRae.
And I'm Chris Evers.
And we're Team 14.
Okay, so here's the diagram for our project. We have a collector rover and a sorter rover. The collector rover finds blocks over here in this pickup area where the blocks are just all over the place, and they're not in a specific order. It picks up a block of a certain color, and then it communicates that information to the sorter rover wirelessly, and then it meets the sorter rover at this meeting line. Then it does the handoff, and it hands off the cylinder to the sorter rover, and the sorter rover has to find the appropriately colored bin and drop it off right there. And it has to match the color of the block, of course.
Hey guys, this is James, and I just want to share with you all my contribution to my team's project. So first, as you guys can see here, I have an arm and a bin. And the function of the arm was to pick up a cylinder and then to ultimately drop the cylinder off into the bin. And then the bin would, through the rover's movement, go to a bin and drop off the cylinder. And how each of them kind of functioned, they were powered by SG90 servo motors. Each motor took in a 5-volt PWM, or pulse width modulation signal, coming from their motor pick. And each would be triggered by a message sent from the navigation thread.
So I was working on the Pixie Cam and the IR sensor in order to help the rovers pick up the object or drop it off, pick up the cylinder or drop it off. So the Pixie Cam was used for finding the orientation of the object and finding how far off the horizontal, how far off the center of the rover it is, because the Pixie Cam detects objects based on hue and color in order to turn both the X and Y location as well as what color the object was. We use the X location of the object in order to help the rover orient itself to move towards the object. So that involved the motors. It would send information to the navigation thread so that the state machine could tell the rover how to move in order to move towards the cylinder in question. And then when it was close enough, this information from the IR sensor would tell it that it was ready to pick up the cylinder. As for dropping off the rover, similarly we use both the Pixie Cam and the IR sensor. The Pixie Cam was supposed to be used for identifying which color bin corresponded to the cylinder it was carrying, and then again it would have to orient itself based on how far off the horizontal the bin was, and then when it approached it and it was close enough, information again from the IR sensor would tell it that it was ready to drop off the cylinder.
So the pieces that I was responsible for were the sensor fusion and the server. For sensor fusion, I was responsible for gathering data from a line sensor as well as a color sensor. The color sensor was used to identify the color of the block as well as the bin that we were trying to drop the block off in. And the line sensor was used to determine when the rover was approaching a boundary line or if either of the rovers was at the meeting point where they needed to hand off the blocks to each other. So the way the sensor fusion worked was pulling in the readings from all of our different sensors, whether that's the line, the color, or from the Pixie Cam, compiling it all into one message via a state machine, and then sending that message over to the server. And the server is also a component that I was responsible for. We were using a network that was broadcasted by a Raspberry Pi, a simple network that all of our Wi-Fi modules on the microcontrollers could connect to, as well as the server, which was hosted on a Raspberry Pi. And the server was hosting a MongoDB database where we could add in all of the sensor data, as well as feedback from the different navigation and ARM threads to allow better communication between all of our picks.
So I worked on the motors and navigation. On one motor pick, there's 2 threads running, the nav thread and the motor thread. The nav thread receives input from the server by getting sensor fusion data from the server, and the nav thread will take that sensor fusion data and put it into its finite state machine, which you can see here. In the depending on what state it's in and the data it sees, it will send a certain command to the motor thread. And the motor thread can take commands such as moving forward a certain distance, moving backwards a certain distance, or rotating left or right a certain angle. And also, depending on which state it's in, it will post navigation feedback, which the arm thread will then use to determine when to actuate. So you can see we start off in the grabbing state, where the navigation thread waits for feedback from the arm to tell it when it has an object to move. And then it'll go, once it sees that, it'll go into the searching state where it looks for its goal, depending on the color of the object, which we also get from sensor fusion. It'll look for one of the bins to move towards, and once it sees that, it'll go into the pursuing state when it starts moving towards the bin, and once it sees a distance less than 2 or 3, it'll stop and go into the dropping state, where it'll then send navigation feedback to the bin or arm thread saying to drop the block. And once we see feedback from the arm thread that says it's done dropping, we'll go into the returning state, where it goes back to the initial meeting position in the playing field.
There were several constraints in our project. First was the cost. Any device or supply needed for any of the rovers, we had to make sure fell within the $250 budget. Secondly was the platform. We had to make sure that all the modules interfaced with the PIC32 microcontroller. In addition, time. We only had 1 semester to complete our entire project, whereas 2 semesters would have given us adequate time to not just design and plan, but to ultimately fully integrate. Then lastly was the overall design. We had to make sure that we used all 4 PIC32s and use some ARM-like actuator in our final project.
On this slide, I'm going to talk about a few of the more important requirements in our project. So the first one is the rovers need to detect where they should meet within 5 centimeters of accuracy. And the rovers will both move in the same method. The rover will capture an initial image of the surroundings. It will identify a unique object in the center of its field of vision. The rover will then rotate on its own axis until the unique object detected matches its desired destination. As a rover moves forward towards its destination, a differential is calculated based on the horizontal offset reading from the PixieCam, and based off how far the unique object strays off the center of the robot's vision. The rover's motors will be adjusted accordingly. And once the rover is within 3 centimeters of the unique object, it will be considered as arrived and stop moving forwards. The second one, the collector rover needs to pick up and carry a block without dropping it. And the third one, the collector rover needs to hand the block off to the receiver rover, or the sorting rover. During the handoff, each rover will move to its set meeting location, and the collector rover will hold the block over the basket or bin attached to the sorting rover. The collector rover will release the block, which falls into the bin of the sorting rover. The sorting rover then needs to determine the correct drop-off area based on color, and then the rover should move to that area within 5 centimeters of accuracy. The sorting rover then needs to be able to dispense the block into the area and basket, and then after that return to its starting location to repeat the process.
As we actually implemented our design, especially during the integration phase, we realized that some of our components were more reliable than others. The color sensor was very consistent with the colors that it was reading regardless of the lighting in the room. However, we found that it needed to be very close in order to reliably get these color readings, which wasn't necessarily the most practical for our rover design. Similarly, the line sensor was accurate when the rover was just placed over a line, but had trouble detecting the lines as the rover was actually moving around because there was a lot of vibration and variability in the sensor's positioning as the rover moved. A lot of our mechanical components were more consistent, which was great. The arm and the bid motions that were programmed were able to consistently pick up and drop off blocks. And we found that our motors did do exactly what we told them to for the wheels. However, these actions didn't always produce the same visible output because we were hard coding distances in order to navigate the rover due to the fact that we didn't have a Pixie cam or IR sensor working, and relying on these hard-coded distances left room for outside variables such as the weight distribution of the rover and the power left in a battery pack to have more influence over how far the rover went. So that was something that really affected our reliability in terms of the rover going to the positions that we were expecting it to.
At the end of our project, we determined that our system was moderately robust. The Wi-Fi module could automatically connect to the broadcasting network from one of our Raspberry Pis, so it did not require additional configurations or user interaction to allow it to connect to our network. In addition, our color sensor was able to distinguish between red, green, and blue colors instead of picking up other color values that it might have sensed. Then lastly, our arm grabber could tightly pick up the cylinder and hold it while the collector rover can move around. So regardless of the movements that the rover made, whether the movements were jerky or fast, the arm was able to hold onto the cylinder and take it to the destination.
As for some issues we had with implementation, first of all, the collector rover doesn't know when it successfully picked up a cylinder, and even if it does, it might not really have a strong grip on it. It might drop it by accident, might not be able to hold it for too long. In addition, since we lack a Pixie cam, we had to deal with a color sensor, which is not always reliable, since first of all, the color sensor doesn't have a long range, and it has to be pretty close in order to detect the color of the object in question. Whereas the Pixie cam has an X offset, which is pretty helpful in guiding the rovers where to rotate, where to move, in order to approach the bin, for example, or the cylinder. So the sorter rover had some issues detecting the color of the bin that it was supposed to be approaching, and that can be attributed to a lack of a Pixie cam.